Hey everybody! So today we're going to be reviewing topic 2. At this point, you should have already done a few of the problems from the worksheet. The goal is to do about 4 or 5 problems. And now what I'm going to do is I'm going to go over all of the answers. This should take about a half an hour. Please make sure that while you're watching the video, you pay very close attention because there is a link in the description. Go ahead and click on that link. That link is a Google form that you are going to fill out while you watch this video. So during this video, I'm going to be asking 3 questions. You don't know what those questions are yet, but while you're watching the video, you're going to need to answer those 3 questions. And that's just for me to make sure that you're watching from start to finish and paying close attention. So let's go ahead and get started. Problem number 1. Understanding domain. All right, so here we go. I'm going to go ahead and read it. I'm going to highlight important things, and then we'll work on it together. A person wants to order ferns for his garden. He checked the price at a nursery and found that the nursery charges $9 for delivery and $5 for each plant ordered. He also noted that there is no delivery charges for an order of $70 or more. Based on his findings, he wrote the following functions. F of n equals 9 plus 5n, which represents the cost of n plans when a delivery charge is included. And then g of n equals 5n to represent the total cost of n plans with no delivery charge. Okay. Then we need to match the domain and match the range, match the domain of each of those 2 functions. So let's think about domain. First of all, domain, let me write this down. Domain represents all the possible input values. All of the possible inputs, so all the way from the least to the greatest. And in this case, we have to figure out, okay, what does the input represent? I know, because I have function notation, that the input is my variable n. That's my input. And I know from reading that n represents the number of plants. So my input is the number of plants, which is the letter n. Okay, then I have these 2 functions. So I know that f of n represents how many plants you can buy with a delivery charge. And I know that there's a limit, right? So the delivery charge, you get a delivery fee or a delivery charge when you spend less than $70. So delivery charge is applied when your order is less than $70. So the question is, because I have 2 different functions, one of them is when you do have a delivery charge and one of them is when you don't have a delivery charge. So the question is, how many plants can you buy without reaching $70? And if each plant, let's see, so it's $5 for each plant plus a $9 delivery fee. And there's no delivery charge for an order of $70 or more. So the question is, how many plants do you have to buy in order to reach that $70 limit, okay? And if each plant is $5 each, then okay, what is 70 divided by 5? You can use your calculator. 70 divided by 5 is 14. So I know that I can buy 14 plants. I can buy 14 plants. If I buy more than 14 plants, then the delivery fee goes away. So I can buy up to 14 plants and I'll be charged the delivery fee, but if I buy more than that, then I will have no delivery charge. So here we go. So that means that the domain for f of n is from 0 to 14. So the domain for f of n, I know that's going to be from 0 to 14, but now I have to think, okay, the domain represents the number of plants. And if I'm talking about plants, can I have decimals? Can I have fractions? Can I have negative numbers? And the answer is no, I can only have whole numbers. I can have 1 plant, 2, 3, 4, 5, 6, and so on. So I can't have any decimals I can't have any fractions, which means that it has to be all positive integers, and we know that 14 is our limit. So for f of n, that's going to be all positive integers less than 14. All positive integers less than 14. Now, same thing for g of n. G of n is representing how many plants you can buy when there's no delivery charge. But I know you have to buy at least 14 in order for there to be no delivery charge. So for this one, and again, we're talking about plants, it has to be whole numbers. So this is going to be all integers. Let's look for it. All positive integers greater than or equal to 14. All right, so there it is. All integers greater than or equal to 14. All right, so that would be my two answer choices. All positive integers less than 14 for f of n, and all integers greater than or equal to 14 for g of n. Okay, next up, question number 2, problem number 2. Again, we're talking about domain, but this time I have a graph, and it's telling me that the graph below shows the path of a model rocket after it is launched from the ground. What is the domain of the function that represents the height of the model rocket with respect to time? So again, it's asking me for domain. And I know that domain is all of the input values, which is the same as all the x values. So I have to think to myself, what is the lowest or the least or the smallest x value, and what is the greatest x value? So I look over here on my graph and I notice that the rocket starts at 0 on the x-axis, and then it ends at the 6. So my domain is everything from 0 to 6. And since the graph is all connected, there's no dots, it's all connected, I know that this would be all real numbers from 0 to 6. All real numbers from 0 to 6. That is my domain. And by the way, this over here, all real numbers from 0 to 20, that would be my range, because the range is all the y values. And if you notice, the rocket goes from the 0 to 20 up and down. The highest point is at the 20, the lowest point is at the 0. So that would be my range, not my domain. So that's problem number 2. And now at this point, I want you guys to click on the link in the description, and you're going to go ahead and answer question number 1. And question number 1 is, what is the color of the sky on a nice, clear, sunny day? So go ahead and answer that question in the Google form. What is the color of the sky on a nice, sunny day? All right, let's go ahead and move on to problem number 3. Problem number 3, understanding function notation. Okay, let's go ahead and read it. Jody decides to ride her bike from her house to the park. The distance she travels on her bike in kilometers is equal to the function f of t, where t represents, let's highlight this, t represents the number of hours she has been riding her bike. Jody rides her bike from her house to the park. Before Jody leaves her house, f of 0 equals 0. And when Jody reaches the park, f of 2 equals 30. From the information given, determine whether each statement is correct interpretation that can be made about Jody's bike ride. Select correct or incorrect for each statement. Okay, function notation. So with function notation, we can always identify the input and the output. So for example, here it's telling me that we're talking about f of t. And you always want to look at whatever's in the parentheses is going to be your input. So they give us two different scenarios. They say that f of 0 equals 0, and they say that f of 2 equals 30. Well, let's talk about what the input represents. I know that the variable t is my input, and then I read in the problem it says t represents the number of hours she is riding her bike. So the input is the number of hours. So for example, when f of 0 equals 0, this is telling me that she has been riding her bike for 0 hours. That's the input. F of 2 tells me that she's been riding her bike for 2 hours. Okay, well then I also have an output. There's my output, and there's my output. So let's actually read again. What does the output represents? The other thing we're measuring here, we're talking about the number of hours, and that's comparing it to the distance. So the distance is my output. So here, 0 means that she has traveled 0 kilometers. Whereas on the second example, 30 represents 30 kilometers. All right, so f of 0 equals 0 means that at 0 hours, she has traveled 0 kilometers. That basically is telling me that she hasn't left her house yet. So she's still at her house, she hasn't ridden her bike yet, she hasn't traveled anywhere. F of 2 equals 30 tells me that she's been riding her bike for 2 hours and she has traveled a distance of 30 kilometers. So let's go ahead and say correct or incorrect. So it takes Jody 2 hours to bike to the park. She travels her bike. Yes, when Jody reaches the park, there's the key word. When Jody reaches the park, that means that she has traveled for 2 hours, so that is correct. The park is located 2 kilometers away from Jody's house. That's not correct because we know that it's not 2 kilometers, it's 2 hours, which is 30 kilometers. So it's not correct. When Jody is at her house, she has biked for 0 hours. Yes, that is correct. So there we go. That was problem number 3. Problem number 4, 2 parts. All right. The function f of t is equal to the mass of a pumpkin in kilograms t days after the seed was planted. So f of t is the mass in kilograms, and t is the days after it was planted. Okay, so this is telling us right away, it's telling us that the input is time, so it's days, and then the output is the mass, it's kilograms. And that's f of t. Okay, so now let's read part A. Which of the following statements explains the meaning of f of 80 equals 30? All right, inside my parentheses is my input. That's my input. Input is days, so I know that this means 80 days. And my output is 3, and I know that output is kilograms, so this means 3 kilograms. So the correct answer would be that the mass of the pumpkin is 3 kilograms 80 days after the seed was planted. So that would be answer choice A. Answer choice A. The mass of the pumpkin is 3 kilograms 80 days after the seed is planted. Part B, which of the following notations conveys the meaning that 41 days after the pumpkin seed is planted, the pumpkin has a mass of 1.2 kilograms. So here we go, 41 days, that's my input, my T. Mass is my output. So I know that the 41 has to go in the parentheses. Because that's the input. And the mass is what that function is equal to, because that's my output. So f of 41 equals 1.2. That would be answer choice D. Okay, it's all about reading this function notation and understanding what is the input, what is the output, what does it represent. Problem number 5, recognizing functions. All right, so I have 3 graphs and I need to determine if it is a function or if it's not a function. And remember, for a graph, if you have a graph in front of you, functions cannot, or functions must pass the vertical line test which basically means that they cannot stack. They can't stack on top of themselves. So you can't have any stacking. Now let's see what that means. So there's one example that very clearly is stacking, and that's graph 3. I'm going to do the vertical line test. When I draw a vertical line through anywhere on that graph, notice how it crosses my function. Well, it's not a function, but it crosses this graph once, twice, 2 times. That won't work. You can only cross the graph 1 time or 0 times. 0 is still fine, and I'll talk about that in a second. But here, it touches that graph 2 times, which means this graph is not a function. Okay, graph 2. Graph 2 is a little weird. Graph 2, I'm going to highlight it because it's a little hard to see it clearly, but it's got 2 branches almost. But it's still one graph. Even though it doesn't connect to itself, we still count this as one graph. And there's something a little weird, right? Like I could draw a vertical line down here and it would not pass that graph at all. It would go straight through that hole. That's actually still okay because remember, the definition is that it cannot stack. That's the whole definition. It can't stack up. And even though I went through the hole, there's no stacking. It just goes right through. It doesn't touch anything. And if I did it over here, for example, that's not going to stack. Even if I do it where it looks like it might stack, it's a little bit hard to tell. Let me see if I can draw a thinner line. If I draw my vertical line, it's really only crossing 1 time right here. It's a little hard to tell. I know it's a little weird. Maybe if I make everything a little bit thinner, you can tell. Let's see. Okay. Yeah, it's only crossing it right here 1 time. So basically this graph does not stack up on itself. So it passes the vertical line test. This one is a function. And then graph 1 is this horizontal line that has 2 little holes. So these open circles are holes. And again, I can do the vertical line test over here, and I'm good. It only crosses it once. I could do it over here. I'm good. If I do it through here, it goes through the hole, which means it doesn't touch the function at all. And that's still okay because it's not stacking. It's simply going through the hole. So as long as it's not stacking anywhere, you're good to go. This is still a function. Okay, so graph 1, yes. Graph 2, yes. Graph 3, that's the only one that's not a function. All right. Now that we've completed problem number 5, I have the second question for you to fill in on your Google form. So go ahead and go back to that Google form. And now you're going to answer question number 2. And question number 2 is, what is your favorite ice cream flavor? You can put whatever you want, but tell me, what is your favorite ice cream flavor? That's question number 2. Okay, back to here. Problem number 6. Here we go. Still trying to recognize what is a function and what's not a function. A bakery sells packages of muffins. The number of muffins, X, and the price in dollars, Y, of their packages of muffins are given in the ordered pairs below. The set of ordered pairs is a relation that is also a function. So it's telling me that this set of ordered pairs, these coordinate points, are a function. The bakery is considering adding a new package of muffins. Which ordered pairs would make the relation not a function? Choose all that are correct. Okay, so whenever you have a list of ordered pairs, coordinate points, I always recommend that we put them into a table because a table helps us to visualize it a little bit better and to organize it a little bit better. So I have 1, 2, 2, 3, 4, 5, 6, 7, and 12, 13. Okay, and this is a function because if I look at the x values, there's no repetition. That's always what you want to look for. You want to make sure that there's no repeating x values. Now it's saying the bakery is considering adding new package of muffins. Which ordered pairs would make the relation not a function? Choose all that are correct. So if I added one of these, which of those would no longer make this a function? So let's take a look. So let's say I added 10, 13. If I added that to the list, would there be any repeating x values? No. All of those are still unique. There's no repetition. So this one would not be an answer choice because we're looking for the ones that would make it not a function. 10, 13 would still make it a function, so that's not what we're looking for. What about 6, 8? If I added that to my list, well, I would have 2 repeating x values. So this would no longer be a function, which means B is correct. Oops. Okay. What if I added 8, 12? 8, 12, adding that to the list, it still doesn't repeat anything. These are all still unique. There's no repetition, so that's not our answer. And by the way, this is select all that apply, so we're still checking to see if any of these work. 4, 3. If I added 4, 3, I have repeating values, so that would not be a function, so that's one of my answer choices. And then finally, 24, 18. There would be no repetition. This is still a function, so that does not count. So we were looking for all of the choices that would no longer make this a function. B and D are the only ones. Problem number 7, which of the following diagrams represent a function? So when you have a mapping diagram, on a mapping diagram, you want to make sure that there's no branching, no branching out. No branching out. It's okay if it branches in, it just can't branch out. So what does that mean? Okay. For example, in answer choice B, I have some branching out. There's actually kind of a lot of branching out, but for example, this one branches out and this one branches out as well. So that's not a function. In answer choice D, we have some branching out over here and some branching out over there. Remember? So that's also not a function. Now, answer choice C is a little weird. There's no branching out, but there is something a little bit sketchy, which is that this value doesn't go anywhere. And that doesn't work out for us because the definition of a function is that every x value has one y value. So if there's an x value, this should be going somewhere, but there is no arrow anywhere, so we don't know where it goes, which means that this is no longer a function. So that one's out. And then finally, answer choice A, this is a function because we have every x value goes to 1 y value. There is no branching out, so we're good to go. That's the only one that is a function. All right, so that was problem number 7. 3 more. Problem number 8, understanding sequences. Okay. A researcher determined the amount of ducks that were in a pond over a 4-year time span. The results are shown in the table below. Select the equation that best models the amount of ducks that will be in the pond during the nth year. Okay, so whenever you have a sequence, just like this one, and this one's already in a table, so that's great. Sometimes you have to put it into a table, but this time they already made a table for you. So all we need to do is pick a pair of points, 2, 78. Remember that the 2 is my input and the 78 is my output. So what we're going to do is we're going to look at these answer choices and we're going to see which one gives me the correct output. So I'm going to start with answer choice A, and I'm going to plug in a 2 for n. So I'm going to find A of 2. And I'm plugging in a 2, and I want that to be 78 because I want it to match my table. So I have to do the math and see if it works out. 2 minus 1 is 1. 14 times 1 is 14. And then I have to do 64 plus 14, which is 78. That's what I wanted. That's great. But just to double check, we're going to do it one more time. You always want to try this out a couple of times, just in case. Let's try it now with 3 and 92. So I'm going to plug in 3. And see if I get 92. 3 minus 1 is 2. 14 times 2 is 28. And then 64 plus 28, 64 plus 28, that is 92, yeah. 92. It works. When you do it twice, if it works both times, then you should be absolutely sure that that is your answer. But you definitely always want to try it at least twice just to check, because sometimes it might work for one pair and then it doesn't work for the second pair that you try. So you just want to double check by doing it twice. So we're good with that one. Number 9, a sequence is defined by the function f of n equals f of n minus 1 plus 5, where n represents the number of the term for n greater than 1 and f of 1 is negative 4. What are the first 4 terms of the sequence? So there's kind of a lot. This is all function notation. You kind of have to read it and understand what it's saying. So let's actually look first at this right here. This is telling you that f of 1 equals negative 4. So this is telling me that the first term is negative 4. So the sequence has to start with negative 4. So now I know that answer choice A is out because that starts with 1, and answer choice C is out because that starts with 0. So now I know I've kind of broken it down. I narrowed it down to 2 choices. Now let's take a look at this. This is what's called a recursive rule. A recursive rule basically tells you what to do to a number to get the next number. So in this recursive rule, let me write this down. This is telling me to take the previous number, and we're going to add 5 to it. That plus 5 is the recursive rule. That's telling you what to do to follow the pattern. So if the first term is -4, that means I'm going to add 5 to get to my next number. -4 plus 5 is 1. Then I would add 5 again to get to my next number, which would be 6. And that's basically what the recursive rule tells you. It's just the pattern that you're following. So since this is the pattern, I know that the correct answer would be answer choice D. -4, 1, 6, 11. All right, last problem. Last problem. Oh, that was it. I'm so sorry. There's only 9 problems. Awesome. So since that is it, we are down to the final question for you to put into, or the final answer for you to put into the Google form for question number 3. So question number 3 is, what is the name of my kitten? And the answer is that his name is Cosmo, and that's spelled C-O-S-M-O. So your answer for question number 3 should be Cosmo, C-O-S-M-O. Go ahead and fill that in, and then you can submit that form. Make sure you have your first and last name and your ID number so that I can record that you watched this video and that you paid attention. And I will see you guys tomorrow. Have a great and lovely day.